This video is going to cover Unit 23, Section 2. Before we get into this similar figure section, I need to cover some terminology. Alright? We're going to talk about ratio and proportion. So let's say you have a pool in your backyard, and that pool, the width of it is 14 and the length of it is 20 feet. So 14 to 20. So the ratio of the two sides is 14 to 20, or you can also say 20 to 14. Okay? So let's say you have a drone and you fly it up and you take a picture of the pool in the backyard, and of course the picture is going to be smaller than the actual pool. So let's say that on the picture the width of the pool is 1.4 inches and the length is 2 inches. Okay, so there's a ratio of 1.4 to 2. Okay, so if these two fractions, 14 over 20 is equal to 1.4 over 2, then these two fractions are proportional. Okay? And they would be because they're the same pool, just different lengths. So this fraction is the same as this one. So all I have to do is multiply top and bottom here by 10. 10 over 10, which is 1. So they're the same. This is more reduced than that one. So these two figures right here are proportional because these fractions are proportional. Now there's another way to look at this, and not just within each figure itself, but from one figure to the other. For example, I can also say that 14 over 1.4 is equal to 20 over 2. Okay? This is a better way to look at it. One side, corresponding sides from this figure to that figure, so the big one over the little one is equal to the big one over the little one. So this is proportional as well. So ratios are when you have the same units, or like for example, we have units of length. I know inches and feet are not the same units, but they're units of length. Now a rate is when you have different units. For example, 55 miles per hour. So 55 miles in 1 hour, that's a rate. Different units, miles and hours. But if I have another rate that is 110 miles in 2 hours, these two fractions are the same. 55 over 1 is the same as 110 over 2. This one is just more reduced. So these two rates right here are proportional because the two fractions are the same. Okay? So if you're drafting, okay, this is just a real simple 4-wall looking house here. Now, a lot of times you'll have, well, not a lot of times, you'll have a scale when you're drafting a house. And this scale here would be, for example, 1 foot in real life is 1/4 of an inch on the drawing. So if you've got a wall here that is 16 inches on the drawing, that means that it would be 4 feet in real life. So 1 over 1/4 or 0.25 is the same as 4 over 16. But we're talking about inches here. Feet to inches, feet to inches. 4 feet to 16 inches is the same as 1 foot to 0.25 inches. Okay. So ta-da! Let's get into the lesson. Let me erase all of that Sharpie there. And I got it erased. Just like that. I should market those erasers. Okay. On page 584, midway down the page, 23-2. Similar figures. Stated in a general way, similar figures means that the figures are alike in shape, but not necessarily in size. For example, the real pool versus the picture of the pool. They are similar in shape, but the size is very different. Congruent figures, which is what we just talked about in the previous unit. Congruent figures are a special type of similar figures in that they are both the same shape and the same size. Okay? So let's look at the similar polygons that we have in figure 2311. Let me go ahead and just bring that in. I think it would be better if we just look at this. Okay, right there. Yep. All right, so corresponding angles of similar polygons are equal, and corresponding sides of similar polygons are proportional. So, for example, they tell us that these polygons are similar. So therefore, B, angle B, is equal to angle B prime. Angle C is equal to angle C prime, and so on. D is equal to D prime, and so on. Now, as far as the proportions go of the sides, side BC over side B prime C prime, so this side over that side, is proportional to this side over this side. Okay? So, this side over this side over that one is equal to this one over this one. AF over A prime F is equal to EF over E prime F. So those sides are proportional. This side and this side are corresponding. So these sides are corresponding sides. So corresponding sides are proportional. Ta-da! Now let's talk about perimeters. Wow, we're real close there. All right, that'll work. So, similar figures have not only their sides are proportional, but their perimeters are as well. So let's say that I have a figure right here. Rectangles are just easier to draw. And another one right here. And let's say that this side is 3, this side is 7, this side is 6, and this side is 14. Okay? So, these are similar because 3 over 6 is equal to 7 over 14. Okay? So the sides are proportional. So therefore, it tells us that if the sides are proportional, then the perimeters are proportional as well. So what is the perimeter of this figure right here? The perimeter of this figure is 3 plus 7 plus 3 plus 7. This is 20. So I'll write that right there. 6 plus 14 plus 6 plus 14. This perimeter is 40. So continuing on here, instead of doing the sides, I'm going to say that the perimeters. So 3 over 6 is the same as 7 over 14 is the same as 20 over 40. So the similar figures not only have their sides are proportional, but their perimeters are proportional as well. All right? So let's take a look at some things here. Let's look at, on page 586, I want to look at number 8. Now the idea here is we have to make a determination on whether these figures are proportional or not, or whether they're similar or not. That means the sides have to be proportional. So I kind of use those two terms interchangeably. If they're proportional, they'll be similar. Okay, so what we have here is a rectangle that is 10 by 14, and the other one is a little bit smaller. what are those? 8 by 12. 8 by 12. Okay, so are these proportional or similar? So 10 over 8, is that or is that not equal to 14 over 12? Okay, so it might not be real obvious right now whether it is or not. So let's reduce this one to 5 over 4. So is 5 over 4 equal to or not equal to 7 over 6? If it's not clear, we can use what's called cross multiplying. So whenever you have two fractions that are equal, so if you have two fractions such that A over B is equal to C over D, then by cross multiplying we say that A times D is equal to B times C. Okay, so what does that mean for this? So 5 times 6, which is 30, is that or is that not equal to 4 times 7, which is 28? No, that is not, obviously, not equal. So therefore, because these sides are not proportional, then these figures are not similar. All right? So let's take a look at, let's look at number 7. Okay, couple trapezoids. So it's given that angle A is equal to angle E, angle B is equal to angle F, C and G are equal, and D and H are equal. All right? So therefore, let's see, how do I want to do this? 1 inch, so I'm looking at DC. 1 inch over HG, which is 1.5, is that or is that not equal to 1.8 or AD over EH? 1.8 over 2.7. So it might not look like it. It could be proportional, but a very sure way to find out is to cross multiply. So 1 times 2.7 is 2.7. Is that or is that not equal to 1.5 times 1.8? Well, let's find out. I'm not going to try that one in my head. 1.5 times 1.8, that is equal to 2.7. 2.7. So it didn't necessarily look like it at first, or maybe you're just really good at math and you could see it straight out. If you did, then that's very good. And you're lying. No, I'm kidding. But cross multiplying tells me for sure 2.7 is equal to 2.7. So therefore, these sides are proportional. So that means that the figures in number 7 are similar. Now I can go through all of the sides. That would be best way to do it. So 2 over 3 should be equal to 1.5 over 2.25, 1.5 over 2.25, and you can see those sides on that. So let's cross multiply that and verify that my assumptions are correct. So 2.25 times 2 is equal to 4.5. So is 4.5 equal to or not equal to 3 times 1.5, which is 4.5? And last I knew, 4.5 is equal to 4.5. So this helps me to confirm what I already sort of knew, that these figures, yes, they are similar.